Okay, this first one up here, what do we have a difference between a chemical and a physical change? What do you want to say about that?
Physical composition does not change.
Okay, so I think the easiest example, the one that everybody knows, would be water as a liquid turning into water as a gas. So what about the other side of that? So composition does change, and that would be something like water turning into hydrogen and oxygen if you use electricity on it. So when we say composition changes, we should be thinking about a formula change. The molecular formula actually changed. All right, how about a unit?
Standard measurement.
So we're definitely measuring something, and needs the standardization means everybody agrees on it. What about the reason that the metric system was developed?
So we'll all be on the same page.
Yeah, so we wanted standardization to be worldwide. And anything else?
More accurate.
No.
It's just easier to know the measurements.
Let's just go with that. It is just easier. That's all there is to it. You don't have to remember any weird unit conversions, strange numbers. You just remember how many times you move the decimal place back and forth. What's it based on? 10, the number 10. Okay, so decimal format this first number. So I've got, I'm multiplying this 2.358 5 times. So 235,800. Do I put a decimal place there after the 0? I can't.
Oh, you can.
I'm not allowed to. Why? If I do put a decimal place there after that second 0, what's that tell you?
There's another 0 after it.
No. That I measured exactly to those zeros. Did the person do this? In the scientific notation, if that was the case, they would have written the zeros afterwards. So whoever did this measurement, their scale only measured to the hundredths place. It didn't measure to the tens or the ones. So you can't tell me. I do need to put the zeros there to let you know that we're talking about something that's 235,000. If I didn't have the zeros there, then I'd be looking at something that was 2,300. So the zeros are just a placeholder to letting you know how large it is, but those zeros do not indicate how accurate that is. So how many sig figs are in that number? 4. It was only accurate to 4 significant figures. Okay, I'm going to convert this one over to scientific notation. So a number, a decimal place, the rest of the numbers, times 10 to the 4th. So what we're saying is, if I take this number right here, and I multiply it by 10 4 times, I'll get that number right there.
I was confused on that, Rob, just because there was no decimal, so I didn't actually answer my homework. So just assume that the decimal place came after the 5. Is that how? And then move it.
Do you mean,
4.
are you asking me is where that 5 on the right, is that the ones place?
Correct. Yeah, I was just.
Assume that's the ones place, yeah.
Okay.
You don't need to put a decimal right there because there's a real number there, right? There's a 5 there. So putting that there, you just make the assumption that that 5 is in the ones place.
Okay, and then move.
And move it appropriately.
Okay.
So this one here, how am I going to change this? How am I going to take that? What am I going to do to that 5.894?
You're gonna move the decimal to the left.
I'm going to move the decimal to the left 3 times because what is it that I'm doing? What's that negative sign in front of the 3 mean?
Dividing.
That means the 10 to the third is in the denominator. So that I'm actually dividing that 5.894 by 10 3 times. So if I divide something by 10 once, the decimal place moves over once. So I'm going to be moving this guy over 3 spots. So I'm going to end up with 0, 5. Is that right? No, that's not enough. Cool. Doesn't want to work for me. How about the undo? That worked. 0.005894. Putting that zero, this zero here, in front of that zero, mathematically it doesn't mean anything. But in the state of Oregon, as a healthcare professional, you need to put that zero there. The reasoning behind it is the decimal place might be mistaken, or maybe the pen doesn't write the decimal place. So let's say that you're trying to write 0.52, all right? But for some reason, the decimal place doesn't get written down or it's not noticeable. And so what's the difference between those two doses? A lot, right? So 100 times difference. So the reason that they decided to put a zero here is because if you saw this number, obviously you know what's going on. But what if you see that number? You're like, that doesn't make any sense. Where's the decimal place, right? Because 52 might not have a decimal place, as we saw in the problem before that. It's not a big deal if it doesn't. But 052 is like, what's going on there? So basically, it's just healthcare institutions, again, trying to get your back by covering you. Like in case literally you put your pen down on the paper and you try to put the dot down there for the decimal place, and for some reason the ink just doesn't come out. I mean, it happens. So this is another way to make sure people don't stumble. All right, scientific notation on this one. So I need to pull this over 1, 2, 3, 4 times. So 9.23 times 10 to the 4 negative. All right, I'm going to do some conversions here. These inches into meters. So 285 inches. 285 inches. I'm going to go, actually, I'm not going to do that. I'm going to go 1 inch is 2.54 centimeters. And then I'm going to go 100 centimeters is 1 meter. And if I do that, then I get the inches to cancel, and I get the centimeters to cancel. And then I get something, which is 2.54, oops, times 2.54, 7.239 meters. Is that good? Sig figs is what? 7.24 meters. So I only get to have 3, and since that's a 9, then I'm going to round that 3 up to a 4. All right, so I'm going to go feet per second. I'm going to turn that into miles per hour. So 24.5 feet per second. And we're going to go miles per hour. So I'm just going to put 60 seconds is 1 minute. And then I'm going to go 60 minutes is 1 hour. When I do that, I get my seconds to cancel and my minutes to cancel. So I've got the hour unit that I'm looking for. And so now I want to cancel out my feet. So I've got, I'm going to miles. So it's 5,280 feet is 1 mile. And so when I do that, I get my feet to cancel out. And so what do I got here? 24.5 times 60 times 60, 5,280. So I got 16.7045 miles per hour. Sig figs on this one? 16.7 miles per hour. Okay, looks good. Tetracycline is available in a liquid form labeled 125 milligrams in 5 milliliters. 0.25 grams of tetracycline has been prescribed. How many milliliters do you administer? So what are we looking for in this problem? An answer with what? I'm looking for an answer with milliliters. Great. So do I have any milliliters anywhere in my problem? I do. So I'm going to take this 5 milliliters. I don't just get to write the 5 milliliters down, do I? What does the 5 milliliters represent? The volume that gives you 125 milligrams of this tetracycline. Great. So I have the unit that I want in the numerator, right where I want it. I have the milliliter where I want it. But it came with the milligram, so I need to get rid of that mass unit. The only other number that I've got is this guy. So I need to use grams. So all I need to do is put 1,000 milligrams is equal to 1 gram. And that'll cancel out my milligrams. And then I can put my 0.25 grams up top. And when I do that, my milligrams get canceled and my grams get canceled. And then I just have 5 divided by 125 times 1,000 times 0.25. 10. Milliliters. Does that look good? Sig figs wise? How many significant figures do I have in the answer I have written? 1. Because the 0 doesn't have a decimal place after it. And that's what I need because it says 125 in 5 milliliters. So there's only one significant figure in the 5. So there's only one significant figure in my answer, and that's going to be the 1 in the 10 part. Granted, if this was actually a medical situation, I'm sure that would say 5.0 milliliters or maybe 5.00 milliliters. But in our case, it was just one sig fig. Okay, let's do this next one. I want to know what the volume of a piece of wood is with a density of 0.92 grams per milliliter, and its mass is 355 grams. So I need a unit that's volume, and the only volume unit I have is milliliter. So I'm going to write 1 milliliter per 0.92 grams. Is it okay for me to flip that number over? It's saying 0.92 grams over a milliliter. So it's the exact same thing if I flip it over and say 1 milliliter to 0.92 grams. And I flipped it over because I'm looking for a unit that has milliliters in it. So I gave myself a unit that's got, or a number that's got milliliters in the numerator. So then I just need to get rid of that grams down there. And if I put 355 grams up top, and when I do that, I get the grams to cancel. And all I have left is this milliliter unit. And so I'm just going to take my 355 and divide it by 0.92. And so I get 390. So I only have 2 sig figs in the 0.92, so there's 2, and then 3 sig figs in the 355. So my answer can only be 2 sig figs. So 390 is my answer. It was like 389 something or other, so round up. How about this last one?
The amount of stuff.
The amount of stuff in an object? When I say, I know. But when I think stuff, I think like the mass, like how much stuff is there. I need a volume portion to it too. Around it? The space that the mass is in? How about this? My sister lived with me when she turned 12 until she graduated from high school, and a couple of times we went on trips, and I would go into her room when we were ready to go to like carry her bag down to the car, and there's like stuff sticking out of it. Like it's a suitcase so full that she can't get everything in it. So put it all together and I like push it down really hard and I close it. And then I pick my suitcase up, same exact suitcase, and it weighs like half the weight. So tell me about her suitcase. It's tightly packed. So how about my suitcase? Not as tightly packed. What is the difference between those two things? The density of her suitcase is higher. So what I want you to think about, a non-scientific way to think about it is how tightly packed is stuff. So how tightly packed are the molecules that constitute styrofoam? Not very tightly packed, right? How about a piece of oak wood? Tightly packed. Like if you're going to be cutting firewood like I am, the poplar we have on our property is not dense. When I pick up one of those pieces of wood, it's very easy. But we picked up some oak that they chopped down in the Dalles, and pick up one of those things, and I know I did not just pick up a piece of poplar. So the oak is much more dense. So the molecules are what in the oak? More tightly packed, or they're compacted together. So I just want you to think about how tightly packed stuff is.